Hi everyone, this is the gas walkthrough for May 3rd. I'm Philip Newman. Today I'm solving Anaglyph Cages by Bill Murphy. We have normal Sudoku rules, 1 to 9 in each row, column, and 3x3 box. Additionally, we have cages in the grid, and these are totally normal killer cages. They are colored, however, because they overlap. So this red cage tells us that these 3 digits cannot repeat. They couldn't anyway. But also that they sum to 19, because 19 is given in the top left corner. But also, the blue cage tells us that these 3 sum to 6. And this cell is part of both of those cages. So we have to consider these overlap cells for both cages. And those are the rules. Otherwise, this is just a normal killer. Just the overlap makes it a little different, and honestly makes it more obvious where you should focus. So let's start with our minimums and maximums. 6 must be 1, 2, 3. 7 must be 1, 2, 4. 24 must be 7, 8, 9. And 23 must be 6, 8, 9. And now let's think through how that's going to interact with the red cages. There are 2 ways of looking at this. I'm going to talk about the way that I actually thought about it when I was solving, and then show you probably an easier way to look at it. But let's think about this 19. The highest this can be is 3. If we have 3 here, we have 16 left over. That's 7 or 9. 7 and 9. If we have a 2 here, we have 17 left over. That's 8, 9. And if we have 1 here, we need 18 in 2 cells that see each other. That's impossible. However, we have a 6, 8, 9 triple here, so this must be the 7. And we know now we have 7, 9 with a 3. So that's one way you can resolve this. Perhaps a simpler way to resolve this is to look at the 6, 8, 9 first and realize the maximum I can put in this cell is 7. And obviously the maximum I can put in this cell is 9. So the maximum total we can have is 9, 7, 3, which is 19. Since we need 19, that must be what we have. And we can do something similar with all of these cages. So 1, 2, 3 here means the minimum we can put in this cell is 4. The minimum here is 1. The minimum here is 6, and that sums to 11. So that must be what we have. Down here, we've got 1, 2, 4 looking over. The minimum is 3. 1 here, 7. That makes 11. So that is resolved. And finally, this cage, we've got 7, 8, 9 looking over. So the maximum here is 6. Maximum here is 9. 6, 4, 9 is 19. So hopefully you followed what I did there. I think that's an easier way to look at it with the triples that Bill has given us. But you can think through the possibilities if you prefer. And that's what I did, just because that's how my brain decided to work. We can do some more in these boxes, though. We've got 6 looking over and up, so this must be the 6. We've got an 8 in one of these cells, so this must be 8. And then these are going to be 4, 5, and we have 4 down here to resolve. Over here, we need 2 and 3. They can't go in these cells, so they must be up here. And then we need 5, 7, resolved by the 7. Here we need 6 and 4 in these cells. Because of this, we need 2 and 5, resolved by the 1, 2. And over here, 7 and 8 can't go in these, so this must be 8, 7. And then these are 3, 5. So that is those boxes are resolved except for our 8, 9 pairs and our 1, 2 pairs, which are not resolved yet. Now, if we look down in this column, and this row, we're going to be able to make some progress on the cages. These digits are from 5, 8, 9. The only one of those digits that can go in a 7 cage is 5. So that makes that a 2, that makes that an 8. So that's just resolved. And we have some pairs there. Continuing in this box, we could fill in some more triples. We might as well do that. At the top and the bottom, you'll notice we have roping here. So even if we weren't totally sure about some of these other cells. As soon as we have this, we know this must be 1, 2, 4 as well. It's the only place for those digits. This is not 8. This is not 2. Okay. Well, we can't quite do that here. We have an 8, 9 in addition to 3 and 7 here, so we'll leave that for now. 4 in 2 cells has to be 1, 3. And immediately that's going to give us a 1, 3 pair, placing a 4. But also, how do we make 8 with this 1 or 3? A 3 here would require 5, and we already have a 5 in the row, so this must be 1, 7. 3 here. Makes that 2 and 1. Makes that a 2. 1 and 3. This is not 7. Now this 9 cannot contain 1, 2, or 3, so it must be 4, 5. It's going to place a 7, 5, 4. 7 down here as well. This is now 6, and 5, and 3. If I can type the right digits, someday I'll get better at that. This is 9, resolving our 8 and 9. Alright, and let's look at the 11 here. 4 would need a 7, but we've already got one in the box. So this is 5, 4 with a 6 in the 11. That makes that 8, and that's going to resolve these. And now we're almost done. We've got a few pairs to resolve, but otherwise this is just classic Sudoku at this point. So let's look at 5 first. We've got 4 5s looking in this box, so that's a 5. 8's going to go in one of these cells, but I don't think we can do that quite yet. What are these? These are 2, 6, 7, 8. Don't think that's totally resolved, but I'm going to pencil mark it because I'm not seeing. There we go. Remove the wrong digit there. So we have a nice big chocolate teapot in that row, so that didn't get us there. We need a 4 in one of these cells. And a 4 in one of these cells, that's not resolved. Where is the thing I'm looking for? 2 in this box. It's eliminated from these. And because we placed that 5, this must now be a 2. Oh, and we have an 8, 9 pair. We could have filled this just like we did over here. I just missed it. So this is a 1. Alright, we need 4, 6, 3, 9. So this is 3 or 9. Does anything else here? Not sure. This is 3 or 7. This is not 1, 2, or 7, so this is 3. And then this is not 2, so it's 1 or 7. The 3, though, resolves this side of the grid. If I can type. There may have been something simpler than that naked single there. That is a naked single. It sees all the digits other than 3. So yeah, if you found something simpler there, let us know, or let me know. Bill probably already knows if there is. But that is going to resolve the rest of the puzzle. So we're just filling in digits now. This is 1, 7, and a 4 to finish it off. And that's the solution. So really neat puzzle. The symmetry around the edges, and then just a little bit of thinking about the overlaps here to finish it off. This breaks the symmetry, which makes it a little harder to figure out where to look at next, but then it feels more like regular Sudoku, I guess. But let us know how you found that. Let us know if you found something simpler than what I used to finish it off. But I will see you next time.